Hey guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at this particular integral here. So the integral of the square root of 25 minus x squared all on x squared dx. So this one we'll be using a trig substitution. So what I mean by that is we're going to be replacing our variable with a trigonometric expression in terms of theta. Okay. So this is like a new type of technique of integration that you would learn. So typically you would use like u substitution if you have like a trigonometric expression where, for example, if you had sine x multiplied by cos x, you would do a u sub there to cancel out the trigonometric expression. Here we're doing the opposite pretty much. We're replacing our variables with a trig expression, so we can use pretty much to break it down using Pythagorean identities. So some common identities that we use in math is some of Pythagorean's ones. So here's an example. If you have sine squared of an angle plus cos squared of an angle, that will always be equal to 1. I think I've got the other ones written down here. I'm just going to double check them as well. Another one is tan squared of an angle plus 1 is going to be equal to sec squared of an angle. Now sec is a reciprocal of a trig function. So sec theta is 1 over cos theta, just for a point of reference. Cosec theta is 1 over sine theta, and cot theta is 1 over tan theta, or cos theta on tan theta, not tan theta, sine theta, because if you recall, tan is sine over cos, so 1 over tan is cos over sine. And then the third one that can be very useful as well is cot of an angle plus 1 is equal to cosec squared of an angle. So these are just some common identities. Here's pretty much some definitions. You probably should know that before going into this, but these are pretty much these identities we'll be using to break down our trigonometric expression here. But we need to make a good substitution. So if you have the following scenarios, this is pretty much the best substitution to make. So if you have some expression like this, we have a squared minus x squared. You can also have the square root of a squared plus x squared. And then finally the square root of negative x squared. Sorry, that's the other way. So you have x squared minus a squared. So these are three scenarios. The common substitution used is to let x equal a sine theta for this one. For this one here, it's to let x equal a tan theta. And for this one down here, it's commonly used to let x equal a sec theta. Okay. Using these, you can break the trigonometric stuff down really easily, and combining with the Pythagorean's identities, you'll be able to integrate stuff really easily. So, in our integral here, we see we've got the first scenario here. So in our scenario, a squared is 25. That means a must be 5. So we want to let x equal 5 sine theta. Okay. So it all starts from that, and I'll rub this stuff out because we'll need a lot of room for this. Okay. Actually, I won't rub that out. I'll just move it to the side just in case you still want to take a look at it. But yeah. If you need to look at it further, just rewind the video, just because it is a video, it's not a class. Too easy. Okay, so move our integral over here because we're going to have quite a bit of room for this one here. So we can substitute it in straight away. This is what we get. So we'll get the integral square root of 25 minus x squared. So this is x, so x squared. Square this entire term, so you have 25 sine squared theta. So if you see sine squared of an angle, what that means is sine of that angle all squared. That's just notation that mathematicians use, okay? So substituting this fella up into here, what we're going to get is 25 sine squared theta, subtract all that, and it's still under the square root. Down here you're going to substitute it as well because there's an x squared as well, so you have 25 sine squared theta dx. Now, we can't integrate just yet because we've got a big problem. We've got two variables in our integral. We need to eliminate one of them. So we are converting to theta, so we need this to be a d theta, not a dx. So To find a d theta, we need to take this expression and differentiate with respect to theta on both sides. So you have d theta on this side, and you'll have d theta on the other side. Because if you do this, on the left hand side here, you'll just have dx on d theta, and on this side here, you've got 5 sine theta. Differentiating with respect to theta, the 5 is a constant, so that doesn't change. Differentiating sine, that turns into cos, so you're going to have 5 cos theta. Rearranging this, you're going to have dx is equal to 5 cos theta d theta. And we can see that is equivalent to dx, so we can substitute that guy up into here. So our integral now becomes the integral square root of 25 minus 25 sine squared theta, still under the square root, 25 sine squared theta, and now we just replace the dx with this expression here because we want our d theta and this extra term here pretty much. 5 cos theta d theta. Now I know what you're thinking, we've made it worse, we've made it so much worse, but we're going to break it down really simply very shortly. So what we're going to do is pretty much use one of our Pythagorean identities once we simplify this. So we can see under our square root here, we've got a 25 here and a 25 here. We can factorize that out if we wanted to. So we'll have 25 of 1 minus sine squared theta, all under the square root. And we have 25 sine squared theta, 5 cos theta d theta. Now we can't apply the square root to this expression here because of this minus sign. So if you recall, if you have the square root of a squared and b squared, you can apply the square root because it's a multiplication or a quotient here. There's a product, not a sum. So you'll have ab, but if you have the square root of a plus b, that is not equivalent to the square root of their individual parts, pretty much. So this isn't true, so we can't apply it just yet. We wanted to have a scenario where you have something times something, not something times something minus something else. So ideally we want to break this guy here into a single term. So if we take a look at one of the identities up there before, we can recall the first one. If you have sine squared of an angle plus cos squared of another angle, or the same angle, that's equal to 1. If I rearrange that, I get 1 minus sine squared of that angle is equal to cos squared of that angle. And we can see this bit here is exactly the same as that bit there. So I can replace that with cos squared of that angle. So our integral now becomes the square root of 25, and I don't need a bracket now, cos squared of that angle, 25 sine squared that angle, 5 cos theta d theta. Okay, we can apply our square root now, so we'll have the integral of 5 cos theta on 25 sine squared theta, 5 cos theta d theta. We can multiply this guy and this guy together, so we'll have on the top the integral of 25 cos squared theta on 25 sine squared theta d theta. We can see the 25's cancel, so you're left with the integral of cos squared theta on sine squared theta d theta. And if you remember, cot theta is 1 over tan theta, otherwise known as cos theta on sine theta. So what we have here is just the integral of cot squared theta d theta. Okay, so that's going to be very important because recall our another identity up here. Cot squared of an angle plus 1 is cosec squared of that angle. So that means cot squared of theta is equal to cosec squared of that angle minus 1. We can replace that straight away because it's going to be very easy to differentiate, integrate that. So if I replace that there, I'll have the integral of cosec squared theta minus 1 d theta. Okay. Now, we have to recall, if you differentiate cot theta, you're going to get negative cosec squared theta. So an integral is undoing a derivative pretty much. So if I were to integrate both sides of this expression here with respect to theta, imagine there's a d theta there, you're going to get cot theta plus a constant is equal to negative the integral of cosec squared theta d theta. Divide by -1, so negative cot theta, and the c doesn't change because c can be any arbitrary constant, plus c is equal to the integral of cosec, oh, I forgot the rest of it, squared theta d theta, which is exactly what we have here. Integral of 1 is just theta, so we'll have this is going to be equal to negative cot theta minus theta plus c. Okay, so if I take my integral, our original integral, and I get rid of my highlights, so I'll go x squared and x squared. If I take that guy and I bring a copy down here and make that bigger, this is equivalent to this, negative cot theta minus theta plus c. Now, this isn't the answer I really want, mainly because we have x's here and theta's here, two different variables. And how can we interlink them? Well, we've just got to remember our substitution. We let x equal 5 sine theta of that angle. Okay. Now, we need to remember what sine theta is. So sine theta is the opposite over the hypotenuse of a right angle triangle. So we need to get this in terms of x's pretty much. So we need to draw a triangle, and we know theta's there. So the opposite, so if I rearrange this guy here, sine theta is equal to x on 5. So my opposite side is my x, and my hypotenuse is 5 pretty much. Okay, so we have 5 and we have x. So hopefully you can see where I made that connection there. So that's my opposite, and this here is my hypotenuse. So what we have here is just a right angle triangle. Now we need to work out what this side is. So we need to use Pythagoras theorem. So if you recall, Pythagoras theorem is this side squared plus this side squared is equal to this side squared. So I'll just write it here, a squared plus b squared equals c squared. So therefore, if I want to work out what this is, let's say this was b. B is going to be the square root of c squared minus a squared, where c is the hypotenuse, so I'll have b is equal to the square root of 5 squared, which is 25, minus x squared. So that side is equal to this, square root of 25 minus x squared. Okay, so I can get rid of that now because we know what that side is. So now we just go do a bit more trigonometry real quick. So recall cot theta is cos theta on sine theta. We know exactly what we have for sine theta. Sine theta is x on 5. Now cos theta is the adjacent, so that's the adjacent on the hypotenuse. So you're going to have, well, square root of 25 minus x squared on 5, that's my cos theta, multiplied by this because you're dividing by it, so you have times by 5 on x, the 5's cancel out, and you get the square root of 25 minus x squared on x. That's my cot theta term in terms of x. Okay, my theta, I can work out theta real quick. All I gotta do is get theta by itself here, so theta is sine inverse of x on 5. So my integral of the square root of 25 minus x squared all on x squared dx is equal to the negative square root, because it was negative cot, of 25 minus x squared on x minus sine inverse of x on 5 plus c. And that is that integral done using a trigonometric substitution. That was a terrible box. Ignore that. But anyway, I hope you enjoyed this video. If you learned something, let me know in the comments below. I'm going to be doing another one very similar to this very shortly, so stay tuned for that.